Next up, we've got distance and midpoint. The first problem, we've got Annika's house, metro stop, and zoo. All right, so for me, I like to think about those 3 points. Let's call this one A for Annika, M for metro, and Z for zoo. And it tells us the metro stop is halfway between Annika's house and the zoo. So in my picture, I've got Annika's house here. And then I've got, let's see which one's in the middle. Metro in the middle, and then the zoo at the end. All right. And I'm given Annika's house is at -11,3. This is not drawn to scale. It's not drawn on a coordinate plane. You could do that if you wanted to. The metro stop is at -3 halves, -2. And then the zoo, that's what we're trying to find. We'll call that one x, y. Couple different approaches to this. We can use that midpoint formula that we have. We can also just simply count. I'm going to go ahead and use the midpoint formula just to try and reinforce that. And we'll take a look at it. So I'm going to start with Annika's. So the midpoint formula, actually let's start with the midpoint formula. Midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. Remember, we're finding those averages there. And so I know that x1 plus x2 divided by 2 should equal the midpoint, which means if we call Annika's house x1, we've got -11 plus x2. I'm just going to use x because that's the one that we're trying to find. Divided by 2 is equal to -3 halves. Now we look at this, we might get intimidated by those fractions. This is nice because both denominators are 2. And thinking back to algebra, we can just take this whole thing, multiply it by 2. And it's going to cancel out that denominator for us. So we got -11 plus x is going to equal -3, which means that x is going to equal 8. And then the same thing with y. Y is kind of nice because there are no fractions. And with y, we've got 3 plus whatever y is divided by 2 is going to equal -2. Read my own writing. Here I'm going to multiply by 2 to get rid of that denominator. Again, same thing I did there. It's just not canceling out this time. And when we multiply by 2, I'll change up my color again. Multiply the whole thing by 2. That's going to cancel out. And that's going to turn into -4 because -2 times 2. Remember, we're distributing to both sides. And 3 plus y. That 2 got canceled out. And we end up knowing that y is equal to, and I'll change my color again, y is equal to, subtract 3, -7. All right, we've got our 2 points. Now I need to write it as a coordinate. So yeah, I'll just go right down here. And we've got x is 8, y is -7. Number 8, find the distance between the 2 points. Here we can draw that picture, kind of think about the triangle. We can also just jump straight to that distance formula. I'm going to go with the distance formula here. Remember that distance formula is the square root of y2 minus y1 squared plus x2 minus x1 squared. And we've got the square root of that whole thing. I'm just going to substitute in. I'm going to use, we have our choice, remember, depending on which way you're more comfortable. I'm going to go ahead and use the second one as my 2 points, x2, y2, and the first one is x1, y1. And so we're going to go through and subtract and do some squaring and all that kind of good stuff. All right, y's first. -1 minus 2, -3 squared, plus 2 minus -4, 6 squared. We end up with 9 plus 36, which is 45. So we've got the square root of 45. A lot of times that's going to be okay. What I'm going to ask is that you make sure that you're simplifying that radical. Remember, we're looking for perfect squares hidden in 45 perfect square factors. Here we've got the square root of 9 times 5, which is going to simplify down to 3 root, wrote 3, meant to write 5, right there. Finding the midpoint, this is straight up application of that midpoint formula. Jumped around on me a little bit. All right, sorry. Straight up application of that midpoint formula. So we're going to average those numbers together. We're going to go x's first. -1 plus -3 divided by 2, comma, -3 plus 6 divided by 2. So we add together our x's, divide by 2. We add together our y's, divide by 2. And we end up with -4 divided by 2 is -2. And 3 divided by 2. And I'm always going to leave that as an improper fraction, 3/2. Now we've got our triangle. Isosceles is key vocabulary term here. We will talk a lot more about isosceles triangles. Right now, the only thing that you need to know is that isosceles triangle has 2 congruent sides. So if I draw this triangle, not to scale, just to give me a picture to work from, I've got A to M to Y. All right. So ideally, I'm going to find the distances. At most, I've got to find 3 distances. If first 2 I try are congruent, then I'm done. So let's talk about the distance from A to M first. So we'll call it AM. And if I look at this distance, I've got the square root of, and we just talked about that distance formula. So I'm going to subtract my y's, and I'm going to end up with -3 squared plus, I'm going to subtract my x's, and we end up with 6 squared, and that ends up, let's see, 9 and 36, hey, what do you know? The square root of 45. Because that's not an answer, I can just leave it like that. I don't need to worry about simplifying it, because I just simplified it. It's easy, but, you know, we'll save ourselves some work now. Next up, I'm going to find that distance from M to Y. So, taking a look at it, we've got our change in Y. 1 minus negative, man, I'm struggling here. 3, 3 squared plus, and again, we've got 3 squared there. For our change in the x's, this is going to be different. It's 9 and 9, which is 18, so we've got the square root of 18. Those clearly are not congruent, so now I need to find that third distance to find out which one I'm missing. So that third distance is going to be right here, that AY. And when I look at A to Y, now I've got to connect those two. I'm going to look at the change in Y, 4 minus -2, which is 6 squared. I'm thinking that we've got a connection here, and then we've got our x's, which are 3 apart. So that's 3 squared, and that is the square root of 45. So those two are the same. So AM is congruent to, that's a symbol that we'll learn later on. It's equals with a little wavy over the top, and AM is congruent to AY. And finally, we've got number 11. Fill in the missing value, so we got equilateral triangle. Again, equilateral triangle, something you've heard before, I'm sure, but we will talk a lot about it later on. And we've got all sides being congruent. Notice here we don't have numbers, we only have variables. So I need to find out how far it is from O to A, and then I need to recreate that distance, not just from O to B, but also from B to A. Whew, all right, we got our work cut out for us. So we need it to be, how far is it from 0, 0 to 2B? Well, that distance is 2B. Let me use the right color here so I can color coordinate. So that distance is 2B, which means my green distance needs to be 2B, which means my red distance needs to be 2B. Let's see. Because I know that I want those to be the same, I also know that they are going to be the same distance, let's see, falling in here and in here. And that's going to split it right in half. So I'm going to look at that and I'm going to think about it that way. And so that means that I'm going to go halfway in between. So I know that x coordinate is going to be b. Because again, I want that to be the same on both sides. I want that to be equilateral. I want it to be the same all the way around. Now, to find that height right there that gets me to a distance of 2b, I'm going to think about that distance formula. And I'm going to use 0, 0, just because it's a little bit easier to throw those zeros out there. And I'm going to think about that distance formula. The distance formula is going to be right here. And I know that I want my x to be b. So we've got b minus 0 squared plus, and then I've got my y value, which I don't know, y minus 0 squared. Let me extend that square root a little bit. And I know that I want that distance formula to equal 2b. Okay, cool. All right, so now I got to do some math. I got to simplify. Because of those zeros, this math is a little bit easier, but we end up with the square root of b squared plus y squared is equal to 2b. I can do a little bit of math here. Let's see what we can do. If I square both sides, let's see what happens. We end up with b squared plus y squared is equal to, be careful here, we square everything, 4b squared. And so since I've got b squared here already, that's 1b squared. I need y squared, or actually what I should do, subtract b squared from both sides. Y squared equals 3b squared. And so I know that I want that, so I'll put the square root of both sides now. And I should be talking about plus or minus here, but because of geometry and because I'm in that first quadrant, I know everything is going to be positive, so I don't have to worry about a negative solution here. Y is equal to the square root of 3 times b. The square root of b squared is b. Just for kind of the sake of math, we write this as y equals b root 3. Just a little bit easier to see that the b is not underneath the square root.